Welcome to a new teardown and test video. This time it's another one of those cool plotters. This one is called a chart recorder, and they changed the name, so now it's not ABB but BBC. That is funny, but it looks exactly like the same kind of design. Connectors, style, everything is exactly the same. And this Goerz Metrawatt is obviously still the same name, so maybe there's a company buyout or selling or something. And it also uses the same pens. Model number is SE120. And this recorder is the dual channel version. As you see here, we got 1 and 2 channels. So the 1 channel version, there's a blank plate in here. Otherwise it looks exactly identical, and it shows here the low pen and the high pen, and they're located on top of each other. So I don't have the original pens for this one, damn it, so I can't really show you guys how well this works. But of course you need to use 2 different pens, preferred 2 different colors. So this pen goes a little bit out and then down, and then the other one is a little bit shorter, so they don't touch exactly the same place. So there will be a time difference because they can't touch exactly the same spot, obviously, because they can move over each other, right? So if the low channel signals gets higher, it will of course pass the other one, right? So that is how it works. So that will be the 2 analog inputs where you can set all the gains and stuff, and that will move each of the y-axis, I will call that, and then the x-axis is the time, and that is the only thing it can do, really. It can do a lot of different times. So that will be 60 centimeter per minute, or 1 centimeter per minute, and then 30 centimeter per hour, or 1 centimeter per hour, as far as I can see, right? I guess this is manual movement of the paper, or this is the direction it is running the chart, probably. Pen lift or do the drawing is manual. So this is the paper holder. I don't know if I did this right, because it looks like you can also, yeah, okay, see? You can also just lift it up entirely. And then you will see the paper is mounted like that. So this is each centimeter. We got the dots exactly like that. This is not compatible with any normal pieces of papers. So this is an A4 sheet. Look, it's just not compatible. So you need the right type of paper to operate this machine. And then there is this lid. You just lift it up, and then you'll see the mechanics. And this is exactly the same mechanics, a complete reuse of the same battery, the same nylon or Teflon or what it is. I wouldn't be surprised if it's the same kind of motor and gearing and feedback we got here in the 2 different drivers. I also tried to measure ohms between the 2 ground inputs, and they're completely floating. So that means the 2 inputs, they're completely floating, so you can use more freely what you want to measure on the 2 channels. So that is a huge advantage. So the machine is now standing on the front. Let's look at at the back panel. So there's a connector for remote control of start, stop and stuff. The paper is neatly mounted here. There's a springy connection or a springy hole here, so you just push it to the right and then it will release the paper reel. So that is how that works. It also looks like there's some sort of expansion possibilities, or maybe, oh damn it, see there's nothing here, so that means these expansions are not installed on this model. And there's a nice holder that just unfolded. Okay, that's pretty neat. It stands really nice here on the table like that. I'm actually a little bit curious how much power this one uses. Oh, I forgot to turn on. Okay, so it does disconnect completely. Ooh, oh shock. That was funny. Oh, they were actually able to move really, really fast. Okay, there is a click click. Let's go closer here. Yes, look at that. Oh, we can even go back as well. I mean, seriously, it works. So this is a manual. Oh, so this is just a manual. See? Ah, that was nice. So you just hold it for a little bit and then... Cool feature for that. So that is the pen left. Yeah, that works. Alright, so... No lock. Variate. What do I do? Okay, this one works. So that is the problem. This one works and this is in cal. It's not reacting to this one. In variable. Not reacting to that. So this is the position. Okay, so we got a dead channel. Nay, no! Yay! So I got good stuff. What exactly does this mean? Ooh. -1, -2. Ooh. Okay, whatever. That, I don't understand that. What that is. So this is in volts or millivolts. Ooh. Magic. Why are you moving? Ah, maybe there's a DC. Let me try and input something. Isn't this just sweet? 2 sine waves, 100 millihertz and 110 millihertz. So that means they will be a little bit out of sync. Maybe we should try and see if we can go faster. So this is more or less full width of the paper, I guess. Let's crank up the speed, shall we? Let's just look at one channel first. So this is 110, 210. What, am I doing something wrong here? Okay, that was 200. 300. Okay, now it goes only to about here, right? Let's go back to 100 and see if it's still the same. Okay, that is the same, right? 500 millihertz. And it's the same. Okay, 1 hertz, and it's still the same. Wow, that's crazy. They can do a 1 hertz sine. 1.5. Okay, see? That's about half the... Yeah, this is minus 3 dB. Look at that. It's 0.6. So that's 1.5 hertz. And that is 1 hertz. And that is 0.5. Alright, I guess this will be the maximum if you want a good stable curve out of it. So I'm super happy. It's really a beautiful product. And it really works. And let's... tear down time. That was super easy. Just 2 screws and then we're in. A really flimsy, thin plastic bottom plate or something. But it doesn't really look like this matches this product at all. Because we got some trimmers and stuff here, and it is just not located anywhere near that. But it's amazingly clean. Look at that. It looks like it's brand new. So look at that. That is amazing. And that was... oh, it's crazy. Okay, I was not supposed to hold... oh, I better get a better grip. I got a shock. Yeah, that will be the 2 different secondaries for the 2 different axes. And there'll probably be a 3rd secondary for the motor system. Or for the timing system. So it's all isolated. Oh, there's a crystal and a processor. Ooh, and an EEPROM and stuff. Wow. And so that will be the 2 motors. And yep, we got some fairly small and crappy DC motors and a little gearing. And then the goody Burns 10 turns, super accurate and precise pot meters. So that is of course why this is super good, because of those pot meters, and they're completely totally sealed, so they will just not pick up dust and dirt, and they will just continue to work forever. This is exactly what you need to do. Do it right. And what is this? A little piece of heat shrink or heat? Or just... okay. I think we should maybe try and see if we can take the sides off. I see some screws right there and up here. So I think the idea is to take the sides off, because I think the rest here is one piece of metal. You're not supposed to take that apart. No. So I take the paper off. Or no, I maybe don't even need to do that. Okay, let me experiment a little bit with a screwdriver. So this is the left panel. Yeah, it was actually quite easy to take off. Just a few screws here and here, and then one in the front. And then you take off the side panel. So that's super easy. Mains goes in. We got a mains selector, the fuse. We got 2 wires going through to the on-off switch. And then I guess you just really? What am I doing wrong? This is not working. Don't you just know how it is when you sometimes just feel like a complete idiot? Everything is so damn easy when you know what to do. There was a piece of metal here that was connecting to a regulator for cooling down to this aluminium. Of course you need to remove this screw, otherwise you can't pull the whole thing up. Oh, it is made so It's not gonna fall. Wow! Why is it that complicated? Full of microcontrollers and shit. What is that? An 8039? Microcontroller with external memory in an EEPROM. I guess that will be for all the timing issues, because this is the timer. Well, this is the timing axis, and what this does, it controls a AC motor, or like a stepper motor, kind of. What is all that stuff doing? Resistors and diodes and stuff. And this goes to this funny motor. And what is up here? What is that? So that will be the motor windings in a wow, in a socket. How sexy! So you can easily replace the motor unit, and just so that will be the wires for the motor. 5 wires. So it's probably a 4-way stepper motor. Yeah, exactly. Look at that. Look at the cables here. So we've got 2 commons and then the 4 windings. That is typically how it's made. And then, yeah, see the 2 red ones. That is the 2 common positives. So it's a 4-step or 4 winding stepper motor, and this resistor is just, of course, in the red common positive. So that means those wires goes down here, where you find, of course, 4 transistors for the 4 steps. Cool. So what is this for then? That is a little bit funny. Now wait a minute. Okay, now I got it. That's actually shielded cables going all the way from the rear panel DIN connector for the remote features, and all those different input signals goes through diodes and resistors for pull up, pull down protection. So that's what it does. Yeah, and that's actually just why we need all those parts for the input, as you see here. All those 5 input signals, they need 1, 2, 3, 4, 5 sets of resistors and diodes to protect the inputs. That's good. So you can't fry the inputs. That is great. And it looks like there are a few configurations with a wire you can jump between those two, and the blue one you can jump through those, probably to configure some stuff. Maybe this board can be used for all sorts of other plotters. But that looks like a really great way to manufacture stuff. It can be done in a split second. Bada bing, bada boom, mount it, we're done. It's super good. Manufacturing and designing parts, you want to have as little different part numbers as possible to design and stock and whatnot. So that will be the 2 screws that goes in from the side. Look, it goes here and it goes there. But see, the other 2 screws, they're not in use here, because it is the same panel that is used on this side, like that, and as the other side, like this, down here. Only one part number fits both sides. Genius! And this is the right side of the unit. Again, I took off the side panel. Now we can see the 2 different pots and the DC motors. Of course, the pot meter is directly connected to the output shaft that's driving the the wire. And look at this one. This is a super cool coupling. It seems to be a little bit loose and stuff, but there isn't any slip-slap in this way. At least I try to move it really slowly and carefully, but I can't make any slip-slap here. You can hear it's like a tenth of a millimeter or something like that. Hardly something you're going to see on the pen movement. So that is really nice. The two inputs, they're using shielded cable. And then it goes to identical input boards. Let me see if I can... Oh, damn it. I need to answer. This is one of the two identical input boards. And again, this is the main transmitter input. Of course, it goes to rectifying diodes, two capacitors, and what we see here is plus minus 15 volts. So it's pre-regulated. And on this heatsink, we will have two transistors, so it's a half bridge. And of course, this is all you need when you got a plus minus supply with a good stable center point because of the two regulators. Then you can make a motor regulator with just a half bridge. And then you'll have op amps and analog stuff for the rest. And the two boards, they're soldered together like this, so it's not really easy to take it apart more than this. However, I can show you guys something that I found a little bit disturbing. Look at those switches. This is looking like it. See those? It looks like it's their own kind of design with some sliders that just moves on the PCB directly to avoid interconnects of any style. So it's just directly on that PCB. So it's quite smart when it comes to minimizing assembly time, wires and all that kind of stuff. But those types of contacts, they're just famous for failing. On this unit, they really work, all of them, and they're completely perfectly stable and all that on this unit. But they're famous for failing. And they're also you see, I need to push them so hard. I'm afraid to break something. A little bit of lubrication maybe or something, but maybe this is all dry. But other than that, yeah, this unit can be assembled in a matter of seconds nearly, right? It's just stick it in, click, click. And that is the paper. Ooh, it's falling. Paper motor and the gearing. And the transformator is beautifully mounted in the middle for good weight stability. So, all in all, I must say, I'm fairly happy about this unit. Can't wait to use it for something funny. What should we record? Maybe some temperatures or humidity or something funny.